Let's learn about histograms. So, I'll just bring this a bit closer so you can see it. What we have here is a histogram. We have the value of our variable along the bottom. This must be some sort of continuous value, time, height, etc. And then along the y-axis, we have frequency density. Importantly, not the frequency. So, what does that mean to say that we have frequency density here? What that means is, if we want to know the frequency of a class, we can't just say that that is equal to area. What we say, equal to height, sorry. We would say that it is proportional to the area. This represents how dense it is. If we know the area of it, similar to when you do volume times density equals mass, in this case, because we're working in just 2 dimensions, we're saying area times density will equal frequency. Okay, so similar to your volume and mass density equations. Okay, so we've got our frequency here, and we know that is proportional to area. So what does that mean? If 2 measurements are proportional, then we say that some constant multiplied by frequency will now equal the area. So, let's look for some information. We're told that there are 8 data in the class 40 to 50. So I know that my frequency for that class is 8, and I can calculate the area. That class has a width of 5. Remember, this is continuous, so 40 to 50 is exactly 5. It's not discrete, there's no rounding error, there are no gaps between these bars. If there were gaps, if it were discrete data, this would be a bar chart, not a histogram. Histograms always show continuous data. So, as we said, frequency of 8, width of 5, and then if we look closely at the height of this, we can see that it's just over 0.3, and in fact, if it shows clearly enough, we can see that is 0.32. Okay, so we have 8 times some constant is equal to our area. K is therefore equal to 5 times 0.32 over 8. 32 divided by 8 is 4, so that's going to give us 5 times 0.04, which is 0.2, or 1/5. That's excellent. We know the constant, so we know that 1/5 of the frequency is equal to area, or if you prefer, frequency is equal to 5 times the area. Okay, so now that we know our constant, we can complete this question. If we can find the area of the class 50 to 60, we can therefore calculate the frequency using our constant. So the area, it's 10 wide, and looking closely, that is 1.8 high. That gives us an area of 18. Therefore, our frequency is going to be 5 times 18. 5 times 18 is 90. So the frequency of that class was 90. Okay, quick summary of the key points for histograms. First of all, it must represent continuous data. We have frequency density up the side, and finally, frequency is proportional to area. Therefore, we need to find that constant of proportionality in order to find areas. And that's how we can work with histograms.